Alright, section 7.4, we're talking about the other trig functions. Okay, so the other trig functions would be tangent, cotangent, secant, and cosecant. Now we've already learned about sine and cosine, and a little bit about tangent. What we need to look at is secant is always the reciprocal of cosine. Cosecant is always the reciprocal of sine, and cotangent is always the reciprocal of tangent. Okay, these two, that's pretty easy to remember. Tangent and cotangent, they're reciprocals of each other. How I keep cosine and secant and sine and cosecant together is, well, this one's got a C, this one's got an S. This one's got an S, this one's got a C. Okay, the C's go with the S. That's how I remember it. Okay. So we know that sine, and we'll say sine of t, we know that that is y over r. And we know that cosine of t, that's x over r. Now, this was not in the unit circle. If it was in the unit circle, we said that r is always 1. Okay? Now, if I take the reciprocal of y over 1, that would be 1 over y, which is what we see right here. Remember, sine and cosecant are reciprocals of each other. Same thing with cosine. If I take the reciprocal of x over 1, well, then I have 1 over x. And that's what secant is, 1 over x. Tangent, which is right here, so I won't write it out. Tangent is y over x. If I flip that to get cotangent, then I get x over y. Now you see these little side notes here. X can't be equal to 0, and y can't be equal to 0. We'll notice what's on the bottom for x not equal to 0. X here and x here. Well, when y is not equal to 0, y is on the bottom. Because if you have a 0 on the bottom, remember this is undefined. Okay? Now let's find the trig functions when they give you just a point on the unit circle. So we're going to find all 6 trig functions given this point right here, negative square root of 3 over 2, comma 1 over 2. Okay, so sine of, we'll call it t because that's the angle that they give us right here is t. Okay, so sine of t. Now remember, on the unit circle, this point right here is represented by cosine, and actually let me write t. Cosine t, comma, sine t. Okay, which means that sine of t is really just, well, that second function right there, 1/2. If I go ahead and find cosine t, is the first function. Let me erase that. Negative square root of 3 over 2. Okay, from there, I'm going to go ahead and find the reciprocal of sine, which is cosecant. So that's going to be 2 over 1, or 2. I'll find the reciprocal of sine, which is secant. So I'm going to flip that, so negative 2 over the square root of 3. Now, can I leave it like that? Nope, because I have a square root in the bottom, so I have to rationalize. So that's going to be negative 2 square root of 3 over 3. That would be your final answer for secant. Okay, now I'm going to move this stuff. Now let's find tangent of t. Now we know back here that tangent is y over x. Okay, so y over x. So y over x. Now, this point here can be represented as x, comma y. We said that sine is equal to y in the unit circle and cosine is equal to x in the unit circle. So this is sine of t over cosine of t. Okay, well, sine of t is 1/2. Cosine of t is negative square root of 3 over 1/2. If I've got a fraction divided by a fraction, then this is going to be 1/2 times, and then flip this bottom fraction here. That's going to be -2 over the square root of 3. These 2's will cancel. Don't cancel that negative. It's going to be -1 over the square root of 3. Again, I have a radical in the denominator, so I need to rationalize. So this will be negative square root of 3 over 3. And that'll be your final answer for tangent. Okay, now if we find cotangent, well, what we would do is we would flip tangent. Okay, we're going to work smarter, not harder here, okay? If I flip this right here, that's going to send this radical to the denominator, and then I'm going to have to rationalize again. But if I look at this answer before I rationalize and flip this one, that sends that radical to the numerator, and then I don't have to rationalize. So I'm going to use that, and I'm going to flip that number. So we're going to have negative square root of 3 over 1. Anything over 1 is just itself. So negative square root of 3 would be your final answer for cotangent. Okay, so we're going to find all 6 trig functions for angle 30 degrees. Now, if we go ahead and I've got it drawn right here, there's my 30-degree angle. This is going to be 90 degrees, which means this has got to be 60. Now remember, if we've got a 30, 60, 90 triangle, straight across from the 30 degree is 1, straight across from the 60 is square root of 3, and straight across the 90 in a 30, 60, 90 triangle is 2. Okay, so I'm going to use those numbers to give me my 6 trig functions. Okay, so we can label this, we'll call it X and Y. Alright, and we'll go ahead and call this R. Alright, so we'll go ahead and find sine of 30, which we know is Y over R. Okay, so Y is 1, R is 2. Done. I'll go ahead and find the reciprocal of that. So cosecant of 30 is going to be R over Y, 2 over 1, or 2. Okay, if we find cosine of 30, that is X over R. X is square root of 3. R is 2. That's it. We'll find the reciprocal of cosine, which is secant of 30, which is R over X. So 2 over the square root of 3. Hey, we've got a radical in the bottom, so we've got to rationalize. So 2 square root of 3 over 3. Tangent of 30 is Y over X. Y is 1. X is square root of 3. Got to rationalize again. So square root of 3 over 3. And then cotangent of 30. Okay, so would I flip number 1 or number 2? If I flip number 1, it's going to send that radical to the bottom, and then I have to rationalize again. But if I flip number 2, it's going to send that radical to the top, and then I kind of avoid rationalizing. So I'm going to flip number 2. So that's going to give me square root of 3 over 1, which is the square root of 3. And then there's your answers for each of those trig functions. Okay, now what we're going to do is we're going to use reference angles to help us evaluate the 6 trig functions. Now remember, a reference angle has to be an acute angle, and it's formed between the terminal side and the horizontal axis, not the vertical axis. And we're going to use all students take calculus just to kind of check and make sure that we have the sign right for each of our trig functions. So all means all of your 6 trig functions are positive in quadrant 1. Students, that means take the s and its reciprocal, so sine and cosecant. In quadrant 2, those are the only 2 that are positive. The rest of the trig functions are going to be negative. Okay, T for take, that means tangent and its reciprocal cotangent in quadrant 3 are the only ones that are positive. The rest of the trig functions are going to be negative. Okay, calculus C, so cosine and its reciprocal secant, those are the only two trig functions that would be positive in the fourth quadrant. The rest of them are going to be negative. Okay, so if we look at this one, we're going to find the reference, we're going to use reference angles to find all 6 trig functions for theta equal to negative 5 pi over 6. So students seem to have an easier time working with degrees rather than with 5 pi over 6 radians, because radians usually have fractions and degrees doesn't. So if you want to take that negative 5 pi over 6 and convert it to degrees, all you'd have to do is multiply it times 180 degrees over pi, and then cancel that out, and you get a negative 150. Remember, that'd be starting on the positive x-axis and going this direction. So that's negative 150. Positive 210, that's starting on the positive x-axis and going this direction. I didn't go all the way. There we go. Okay, so that's a positive 210. It will describe the same terminal side. It's just 2 different ways of going about it. Okay, now if you don't want to use, or you don't want to convert it to degrees, how you can look at it is, well, number 1, it's negative, so we're going to be starting on the positive x-axis and going this direction. Okay, maybe going this direction. Now notice, if this was 6 pi over 6, well, that would just be pi, which would go all the way to this right here because this is pi. Now, it doesn't completely go to 6 pi over 6. It goes to 5 pi over 6. So it's a fourth, or sorry, not a fourth, a sixth of a pi short of being a full pi. Okay? So if it goes here and it's just a sixth of a pi to a full, going a full pi, so that means that this little piece right here, you can call it 30 degrees, or this little piece right here is pi over 6. That's another way of thinking about it. Okay, so there's a couple of ways you can get to that terminal side. But the main idea is, what you're trying to do is you're trying to get that reference angle. And notice that this angle is between the horizontal and the terminal side. So this little piece right here. Okay, now if we had found degrees and we stick with the 210, well, how do we get to the 30? Well, since we're in quadrant 3, it's going to be the angle they give me minus 180, and that gives me 30. Okay, well, straight across the 30 is negative 1 because this is 90 and this has got to be 60. Straight across 60 is square root of 3. And by the way, this is negative 1 because we're on the negative side of y. And this is a negative square root of 3 because we're on the negative side of x. And then you've got 2 if you're in a 30, 60, 90 triangle and you're talking about the hypotenuse in that triangle. Okay, once you've got all that, then you're ready to find all 6 trig functions. Because this is your r, this is your y, and this is your x value. Okay, so sine of 210 will be y over r, so that'll be negative 1 over 2. The reciprocal of sine is cosecant, so that'll be r over y, so that'll be negative 2 over 1, or negative 2. Cosine of 210 will be x over r, so negative square root of 3 over 2. Radical is in the top, so that's fine. Secant of 210, which is the reciprocal of cosine, will be negative 2 over square root of 3. We've got to rationalize that. Negative 2 square root of 3 all over 3. Tangent will be y over x. Okay, 2 negatives, that gives me a positive. And then I have to rationalize. And then cotangent of 210, not going to flip this one, but I will flip this one. So square root of 3 over 1, or square root of 3.